Okay, picture this. You've got a set of rules, laws of physics, right, that have worked perfectly for 300 years. I mean, perfectly. And then one day, they just break. What would it take for something like that to happen? For science to get something so wrong that they had to throw out the rule book and start all over again?
Well, that's exactly what happened at the turn of the 20th century. It sparked one of the biggest crises in the history of science, seriously. So let's go on a little journey, you and I. We're going to find out what went so disastrously wrong with classical physics that a whole new science had to rise up from the ashes.
All right, first, let's set the scene. Before all the chaos, for centuries, physicists thought they had it all figured out. They saw the universe as this magnificent clock. You know, every gear, every spring, every tick and tock was perfectly predictable. Everything had its place, and you could calculate its past and future with absolute certainty.
And for the better part of 300 years, this whole belief system rested on three huge pillars. You had Isaac Newton explaining motion, James Clerk Maxwell nailing down electricity and magnetism, and thermodynamics explaining heat. And together, wow, they created this perfect, beautiful system. I mean, from an apple falling from a tree to a planet orbiting the sun, these laws just worked. They were flawless. A lot of scientists at the time genuinely thought, well, that's it. Physics is pretty much solved.
But then, nature started dropping these tiny little hints that something was, well, deeply wrong. It all began with these small experiments, right? Scientists started looking at things that were really, really small, like atoms, and things that were incredibly fast, like light itself. And it was in those extreme places that the perfect, predictable, clockwork universe, it just started to fall apart.
And look, we're not talking about small errors here. This wasn't just a miscalculation or a rounding mistake. No. These were direct, in-your-face contradictions. Problems that completely shattered the old laws and left the smartest people on the planet absolutely stumped. So, let's take a quick look at three of the most famous failures. Three big mysteries that classical physics just could not explain, no matter how hard anyone tried to make the old rules fit.
Okay, first up, the photoelectric effect. Now, this one was just bizarre. It was a total reversal of what everybody expected. The old physics was clear. A brighter light has more energy. Simple, right? But in experience, you could blast a piece of metal with a huge, blindingly bright red light and nothing. Not a single electron would budge. But then you shine this tiny, faint little violet light on it, and bam, electrons start flying off instantly.
This was completely backward. I mean, the rules were so simple. Brighter light means more power, more punch. But nature just wasn't playing by the rules. It was like the universe didn't care how bright the light was. It only cared about its color, its frequency. And that just made zero sense at the time.
All right, the second problem? This one was even crazier. It was existential. See, according to the laws of electricity and magnetism, an electron orbiting a nucleus it must radiate energy away. It's like a tiny broadcasting antenna. And if it's losing energy, it should spiral into the nucleus in like a trillionth of a second. So, if that was true, every single atom in the universe should have collapsed almost instantly. The fact that atoms are stable, the fact that you and I are even here talking about this, was proof positive that the theory was dead wrong. But of all these cracks appearing in the foundation of physics, there was one mystery that was so deep, so completely impossible to explain, that it became the final nail in the coffin. This was the problem that truly broke physics and forced a revolution. And it all came down to something called Blackbody Radiation. Now that sounds super technical, but it's actually really simple. It's just the glow that every hot object gives off, like a glowing piece of iron from a blacksmith, or the filament in an old light bulb, or even the light from a star. And scientists thought, hey, we can use our perfect classical laws to predict the color and energy of that glow. The results? Oh, it was an absolute disaster. I mean, the results weren't just a little off, they were spectacularly wrong. Just look at this. On one side, you have reality, what we actually see. It's this nice, predictable, elegant curve of energy. But on the other side, that's what the classical equations predicted. The theory said that any hot object should be blasting out, get this, an infinite amount of energy, mostly as super high-frequency ultraviolet light. Infinite. This failure was so complete, so absolutely epic, that it got an appropriately dramatic name, the Ultraviolet Catastrophe. Think about what it means. If the theory was right, just turning on your oven to bake a pizza would flood your kitchen with a wave of deadly, infinitely powerful radiation. I mean, this wasn't just wrong, it was absurd. It was the final, undeniable proof that the old physics wasn't just cracked, it was completely shotter.
So what do? The most trusted laws of physics are lying in ruins around you. Well, a German physicist named Max Planck came up with a solution. And it wasn't some elegant, beautiful new theory. It wasn't based on anything that came before. In fact, he himself called it an act of desperation.
What he suggested was basically heresy. He proposed breaking one of the most fundamental rules of the game, the idea that energy is smooth and continuous. You know, that it flows like water from a tap, and you can have any amount you want.
He said, okay, what if, just what if, energy isn't continuous? What if it only comes in tiny individual packets? He called these packets quanta. This meant you couldn't have half a packet of energy or 1.3 packets. It was all or nothing. You could only have whole numbers of them. Now, this was a totally wild, off-the-wall idea with zero evidence to back it up, except for one tiny crucial detail. When he plugged this crazy idea into the math, it worked. It worked perfectly.
And here's where it gets truly mind-blowing. This one simple-sounding idea, this desperate guess about energy packets, it didn't just fix the ultraviolet catastrophe. It turned out to be the master key. It also perfectly explained the photoelectric effect, and it explained why atoms are stable. This one single idea became the foundation, the very cornerstone of a bizarre new reality, quantum mechanics.
But think about it. A universe where energy comes in little chunks instead of a smooth flow is a really, really weird place. So how did this one radical concept completely reshape everything we know? How did it lead to quantum leaps, the uncertainty principle, and all the other strange stuff you hear about? Well, that's the story for our next explainer. We're going to dive deep into Planck's solution and the truly bizarre and wonderful birth of quantum theory.